And finally, final piece of information before we start doing the problems. Our answer, has to be positive x is less than or equal to or greater than or equal to some value, not negative x. So we have to make sure we end up with a positive x, and how we do that is we just multiply both sides by -1, okay? And so if we multiply both sides here by -1, we'll end up with x and -7. -1 by x is -1 by -x is x, -1 by 7 is -7. But look what's happened to the sign. We must flick the sign when we multiply by -1 both sides. When we change the sign of the x, we flick the sign of the inequality. Okay, so it's gone from that way to that way, and this has gone from negative to positive. Really, really important rule. So here's an example. Solve 7 minus 4x is greater than or equal to 2x plus 1. Now, we're told that x is an element of real numbers, so automatically our number line will have a thick line. And we have a greater than or equal to sign that signifies a full dot in the answer, rather than if it was just greater than, that would be an open dot. Okay. So let's keep x to the left here. So I have minus 4x, bring over the 2x, minus 2x is greater than or equal to 1, bring over your minus 7. So 7 becomes minus 7. Okay, as it crosses the sign as in the previous algebra we've met, solving the linear equations. Okay, so minus 4x minus 2x is minus 6x, greater than or equal to 1 minus 7 is minus 6. Now I want to change this sign, and I do this, fix the sign of the x as soon as possible, multiply both sides by -1 and flick the sign. So do this at the earliest opportunity. Okay, so 6x is less than or equal to 6. So the sign has flicked, it's changed direction from this way now to this way. Okay, and this has gone to positive 6 because I've multiplied both sides by -1 and the sign is flicked. So x then is less than or equal to 6 over 6. X is less than or equal to 1. So I draw my number line, and I have 0, 1, -1, -2. I have a full dot because of this symbol here. Sorry, 0, 1, -1. I have a full dot, and x is less than 1. So x is less than 1. Apologies, x is less than or equal to 1. So that's why it's a full dot that sits on the 1, and so it includes the 1. It's less than or equal to 1, and any numbers down that way along the number line. Now, a more advanced example, but still using the same theory. So find the solution set of C. Solution set C of 2 less than or equal to 5x minus 6 over 2 natural numbers. We're going to talk about find the solution set of D, find the intersection of C intersection D, and illustrate this in the number line. So the first thing, let's find the solution set C. So basically it's just solve, not solve, it's find the value for whichever x is less than or equal to or greater than or equal to, or whatever. Okay. So the fact that it's a natural number, we're going to talk dots, we'll see those in a minute. So let's roll with this then. So first thing to do is we can just cross multiply 2 by 2 is 4, less than or equal to 5x minus 6. Keep my x to the left, bring the x over here, becomes minus 5x, bring the 4 over is minus 4. Okay, so minus 5x equals minus 10. Fix the minus sign, so multiply both sides, minus by -1. -1 times this is 5x, -1 times that times minus 10 is 10, and flick the sign. The sign is flicked over now, okay? It's flicked over the other way. So x is greater than or equal to 10 over 5, which is 2. So let's, this one, 5x minus 6 is part 2 to find the solution set D. X is natural number, we'll use dots again, that'll become clear in a while. 5x minus 6 equals 2 by 7 is 14, or is less than or equal to 14. 5x is less than or equal to 20, x is less than or equal to 20, over 5, x is less than or equal to 4. So what have we got so far? We found that x is greater than or equal to 2. and x is less than or equal to 4. So x is between 2 and 4. So if I write my x greater than or equal to 2, less than or equal to 4, this is putting both of these, this is putting the intersection of these in the one statement, okay? X is less than or equal to 4, greater than or equal to 2, okay? X greater than or equal to 2, x less than or equal to 4. I used LT and GT. So on the number line, I'm not using a really thick line, I'm not dealing with real numbers. There's no need to talk about open dots or full dots, they only work with the thick line anyway. When we talk about integers or natural numbers, then we're talking dots, and so x is greater than or equal to 2, and it's less than or equal to 4, so it's either of these, and because they're the natural numbers, from natural numbers, we're talking only about whole positives 2, 3 and 4, nothing in between. That's why I don't use a thick line. I'm not counting everything in between. I'm just 4, 3, 2. They're the values of x for which those solution sets hold true. Okay, let's look at simultaneous equations, and in this course you'll work with simultaneous equations in kind of 4 different ways: straightforward solutions, solving simultaneous equations arising out of stories, concerned with graphs or concerned with shapes of some sort. Okay, so, and just another thing to notice about simultaneous equations is that we're introducing a second unknown. So we've had x all along, and now we have x and y. Okay, and we're looking to find a value for both x and for y. Okay, so the first type is the straightforward solving question. So solve the simultaneous equations: x minus 2y equals 9 and 3x plus 7y equals 1. And I always note one as this and the other as 2. Okay, so the idea is that we're looking to make both equations have either the same multiple of x, 3x and 3x, or 7y and 7y. Okay, same multiple of x or y, then this will mean that we can kind of cancel them out and be left to isolate one x or y and find a value for that, plug that back in, and we can find the value for the other. Okay, so we need to make the coefficient of x, in this case 3, and to do that we need to multiply all the terms here by 3, because that keeps the equation balanced. Do unto one as you do unto others, and so on. So, if we're going to turn this into 3x by multiplying by 3, we have to multiply this by 3 and this by 3, and that the equation holds true and remains balanced, and we can still work with it. So, x minus 2y equals 9, 3x plus 7y equals 1. Multiplying everything here by 3, we get 3x minus 6y equals 27. Now we can cancel the 3x's by, I always say, changing the sign of all the terms in 2 and adding this equation to that equation. And we can change all the signs in 2 by multiplying all the terms here, the 3 terms, by minus 1. Whatever I do to one, I do to the other, and that keeps this equation balanced this time. Okay, and you'll always multiply to change the sign by minus 1, because I want this to be negative, so I can say 3x minus 3x and I can cancel them out. That's where I'm heading with this. Okay, so here we go. So here we go. If I multiply all of these by minus, I end up with minus 3x minus 7y equals minus 1. 3x minus 3x, goodbye. 6y minus 7y is minus 13y. 27 minus 1 is 26. Y is equal to minus 2. Now I sub the fact that y equals minus 2 back into either equation, 1 or 2, to find x. So if x minus 2y equals 9, that's saying that x minus 2 times minus 2 is equal to 9. Minus by minus is plus, 2 by 2 is 4, so x plus 4 equals 9, which must mean that x is equal to 5. X is equal to 5 here. The second type of problem you might meet with are concerned with simultaneous equations that are born out of stories. So here's one here. Juniper chocolate bars are made in 2 sizes, regular and large. 2 regular and 5 large weigh 760 grams. 1 regular and 7 that should be large, weigh 920 grams. How much does a regular bar weigh? And how much does a king size or large bar weigh? Okay, so the trick is to let x equal regular and y equal king size or large. So we've 2x plus 5y equals 760. There's one equation generated, and 1x plus 7y equals 920. That's the second equation generated. Okay, we need to make this into a 2 so that we can cancel it with that one there. So we multiply everything along the bottom by 2x plus by 2. So we get 2x plus 14y plus 2 times that is 1840. Now we multiply everything along the bottom by minus 1, so we can set it up to cancel the 2x. And we can say 2x minus 2x is goodbye. 5 minus 14 is minus 9y equals minus 1080. Y equals 120 grams. And if I put y equals 120 back into our first equation here, I get 2x plus 5 times that is 760. 2x is 760 minus that is 600. X is equal to 80 grams. So the regular bar is 80 grams and the large bar is 120 grams.